So far, we've looked at data that has a numeric value. We've looked at grade point average, height, weight. You could look at shoe size, how long somebody held their breath, and we calculated statistics on that. We looked at the mean, the median, the mode, the range, and the mean absolute deviation. Then we added a second variable where we might have looked at grade point average versus time studied, height versus weight. Suddenly we were comparing two numeric values. That's when we created scatter plots. We looked at line of best fit and we drew conclusions about correlation and then possibly causation. Now we're going to look at the other way to compare two sets of data. But we're not dealing with numeric data anymore. We're dealing with categorical data. For example, 21 people drive a sport utility vehicle. There's no way for me to make this a number. Just as you ask questions about gender, so we get an answer for male, an answer for female. Again, there is no numeric way to describe those for our study purposes. So this is all categorical data. And the way that we summarize categorical data is by using a two-way frequency table. It examines the relationships between two values or two categorical variables. They're important because we can determine trends, we can look at parts of the whole in terms of percentage and all that good stuff. All right, so let's start by looking at the entries in the table, the joint frequencies. And the reason they call these joint frequencies is because the number 21 describes two different variables. There are 21 people that drive a sport utility vehicle, and 21 of them are males. There are 135 people in all that drive a sport utility vehicle that are also female. There are 39 people that drive a sports car that are also male. Now I'm going to switch it on you. There are 45 people that are female that drive a sports car. So these are called my joint frequencies because they measure more than one category. Sometimes I want to know totals. So in order to find the total of males, I will add a cross and find my row total here, the total number of females. And then I can look at my column totals. There are 156 sport utility vehicle drivers and 84 sports car drivers. And notice that these totals occur in the margins. So we call them the marginal frequencies, okay? And they tell you up here, these are the sums and totals of the rows and columns. And also notice here, this is the total of the totals. So I've surveyed 240 people and they're broken down in this way. Now, sometimes I'm not going to be concerned with the number of people that drive a car. I'm going to want to look at how they relate to the whole, or I'm going to want to look at the percentage. So when we look at the percentage of data, we are looking at a two-way relative frequency table. How do these numbers relate to each other by count or frequency? And these will be displayed as a ratio, a decimal, or a percent. So you'll see that these values are in decimals, but I will want you to then convert them to a percent, okay? So the way we find the relative frequencies is we're going to divide all the cells by 240. And I want to look at my calculator for a second because I have a feeling I just want to sort of demystify or clear up any common misconceptions. So here is a common misconception that I see. A lot of people are tempted to see 21 divided by 240, but then they are so used to writing or dividing the larger number by the smaller number that we get a different value. What I need is a percentage. So we're going to take 21 and divide it by 240. And notice that's where we get 0.0875. If we're dealing with percentages, we want to go to the hundredths place or two places. So that means I need to look at this 8. So I have to determine, do I keep the 8 or do I round it up? Well, what does the 7 tell me to do? The 7 tells me to round the 8 up to 9. So that's how they get 0.09. And then for our purposes, we are actually going to make this a percent. So remember, we'll shift 2 decimal places. And so we end up with 9% here. For females that drive an SUV, we're going to take 135 divided by 240. And notice again, we just only are concerned with 2 decimal places, the hundredths place. So this will become 0.56. And again, we're going to shift 2 decimal places. So this is 56%. 156 divided by 240 is 0.65, which becomes 65%. And notice here that whenever we're dealing with whole table frequencies, the same way we added these two numbers to make the column total, we can add these 2 percents to get the total for the percents. All right? So 0.16 will become 16%. 19 hundredths becomes 19%. We get 35% here. This is our good friend 25%. Another that we're common percentage is 75%. And notice here, when we shift 2 decimal places, we do end up at 100%. So this is the background for our table. This is sort of everything that we need to know about it to kind of help us whenever we study some data. All right, so now let's look at some actual numbers, and let's see what we can fill in for these. So I want to use the frequency table here to answer some questions. All right, there we go. Okay, so one thing that's going to help me is I need to fill in my table entries here. So in order to do that, make sure you have brushed up on your arithmetic skills, or make sure you have a calculator handy. And I'll tell you that I'm not always the best at mental math, and there are many of you that can attest to that fact. So I'm going to use my calculator. All right, so let's fill in some values that we know. So we know that there were 400 people surveyed in all. So let me see maybe if I can start by filling in some totals down here. So I have 400 people that are being surveyed, and I am missing this value. So I think the best way to find this value is to take the 400, let's subtract the 200 that are there and the 140 that are there, and I will find that I have 60 people here that order no drink. Likewise, I can find this missing row total because I know out of the 400 people surveyed, let's subtract the 158 that buy a hot dog. Let's subtract the 182 that buy a pizza. And we will be left with 60 here that do not order food when they go to the concession stand. All right, so that's how I found those values. So what's the next value that I can find? Well, I can look here. I see that 50 plus 120 people, 170 people ordered hot dog or a pizza out of the 200 that ordered soda. So 170 plus what equals 200? Well, if you do your mental math, that's 30. If you need to see the calculator math, we'll take our 200 people minus the 50 who order a hot dog minus the 120 who order a pizza, and we're left with the 30 that order no food. Let's see, what else can we fill in? Yes, right here. There are 60 people in all that ordered no drink. 10 ordered no drink and no food. 4 ordered no drink and pizza. Let's find out who does not order a drink, but also orders a hot dog. So let's take our total of 60, we'll subtract the 10, we'll subtract the 4, and we're left with 46. And couldn't I just say 60 minus 14? I could. I get the same answer either way. I want you to use the method with which you're most comfortable. All right, let's see what's left. Well, I can't really fill in these columns because I'm missing 2 values. But if I look at the rows, I see that I have just 1 value missing in the pizza row. So I can find this number. And I'll find this number by taking 182. I'll subtract the 4 that have no drink. I'll subtract the 4 that order a soda, and I'll see that 58 people will order a pizza and water. All right. And now let's look at our final missing row value there. I have to do that slowly because I still have issues determining what is a row and what is a column sometimes. It happens. All right, so let's look at this. We have 60 people who order no food. Let's take away the people who order no drink. And let's take away the people that order 30. Because isn't that what subtraction is? It's finding missing values. So our missing value here is 20. So there are 20 people that order no food but order water. Okay, so let's see if we can answer a few questions here about our data. All right, so how many customers purchase soda? Well, everyone who purchases soda is here. We have 50 plus 120 plus 30. So there are 200 people that purchase soda. How many customers purchased a hot dog? Well, let's find our hot dog row, and we find that total to be 158 people. So 200 people purchase a soda, 158 purchase a hot dog. How many customers purchased a soda and a hot dog? Well, to find who purchased a soda and a hot dog, we look at our joint frequency here. So there are 50 customers that purchase a soda and purchase a hot dog. Okay. All right, and now we're going to talk about some percentages. So let's look at some of these and make sure we sort of understand what's going on here, okay? And so that I can fit everything into the camera nicely, I've sort of recreated the table, and I'm going to put that here just so that we can look at the rest of our values, okay? What percentage of customers purchased a slice of pizza and a bottle of water? All right, we're dealing with percentage. We're dealing with a percentage of total customers. So when we look at this, you remember the is over of equals percent over 100? Well, the same rule applies here to tables. So we're going to look at a percentage of customers. There are 400 customers in all. How many purchased a slice of pizza and a bottle of water? So we'll go here to pizza and water. So that's 58. All right, so they asked us for a percentage. So let's find the decimal by dividing. And remember, it's the numerator divided by the denominator. Don't try to look at large and small. Numerator divided by denominator. And for our decimal answer, we'll get 145 thousandths, but they want a percentage. So in order to find the percentage, remember, we've got to go 1, 2 places. So this will be 14.5%. Okay, not bad. Not bad at all. What percentage of customers, again, we're dealing with customers here. So out of 200, purchased a soda and no food. So let's look for soda and no food. That's here. So we have 30 out of the 200. And so when we divide 30 divided by 200, we get 0.15, 15 hundredths. And then in order to convert that to a decimal, remember we shift to our decimal to the right 2 places. And so we are at 15%. All right. What percentage of customers purchased a slice of pizza and a bottle of water? So let's see what happens with this one. I'm going to slide that just a smidge. All right. So percentage of customers who purchased a slice of pizza and a bottle of water. Pizza and a bottle of water is here. So that's just like number 6. So 58 divided by 400. We already found this as 14.5%. And it took me a minute. I thought, why are we repeating this question? But I remember why. Okay, so far all we've done is look at the percentage out of the number of customers. So we've looked at a denominator of 400. That's out of all of the customers that have been surveyed. Okay, but we're going to change things around just a little bit. Okay, so my main focus now is on numbers 6, 7, and 8. Let's see if we can adjust this. All right. What percentage of customers who purchased a bottle of water? Oh no. Customers who purchased a bottle of water. So we're only looking for a percentage of those. That means our denominator has changed. How many customers purchased a bottle of water? That would be here at 140. So out of the 140 customers, how many purchased a slice of pizza? Well, that's this number, 58. Okay, so notice we still have our joint frequency of 58, but we're looking at this out of a different number of people. So when we take 58 and divide it by 140, we're going to get a nice pretty decimal here. So let's take this to 0.414. It's about equal to 0.414. And then to convert this to a percent, we end up at 41.4%. Okay, let's look at the next one now. What percentage of customers who purchased a slice of pizza also purchase a bottle of water? All right, we've changed things here. Now it's out of customers who purchased a slice of pizza. How many people purchased a slice of pizza? There it is, 182. So now we're taking this out of 182. Also purchased a bottle of water. So we still have our same numerator here. So it's the denominator that changed each time. So we'll take 58 divided by 182. Oh, and that's approximately equal to, this is 3, 1. What does the 6 tell the 8 to do? It tells it to round up to 9. Okay, and this becomes 31.9%. So notice what happens here. These 3 situations involved pizza and water, but we looked at the different counts of how they're related, okay? So 14% of everybody purchased pizza and a bottle of water. 41% of water buyers bought a slice of pizza. 31% of pizza eaters bought a bottle of water. So notice the percentages are different because we're changing our original counts. So from here I can ask you questions. Who's more likely to purchase whatever? That's how I can look at it. Out of the water drinkers, which situation is more likely? Buying pizza or whatever the case may be. Okay? So that's sort of a review of two-way tables in a nutshell. Make sure you can identify the joint frequencies, the marginal frequencies, be able to understand that 4 people bought a slice of pizza and no drink, and then be able to calculate percentages